Galvani was so confident of his ideas, he even sent a copy of his book to Volta. But Volta just couldn't stomach Galvani's idea of animal electricity. He thought the electricity just had to come from somewhere else. But where? In the 1790s, here at the University of Pavia, almost certainly in this lecture theatre, which still bears his name, Volta began his search for the new source of electricity. His suspicions focused on the metals that Galvani had used to make his frog's legs twitch. His curiosity had been piqued by an odd phenomenon that he'd come across: how combinations of metals tasted. He found that if he took two different metal coins and placed them on the tip of his tongue, and then placed a silver spoon on top of both, he got a kind of tingling sensation, rather like the tingling you'd get from the discharge of a Leyden jar. Volta concluded that he could taste electricity, and that it must be coming from the contact between the different metals in the coins and spoon. His theory flew in the face of Galvani's. The frog's leg twitched not because of its own animal electricity, but because it was reacting to the electricity from the metals. But the electricity his coins generated was incredibly weak. How could he make it stronger? Then an idea came to him as he revisited the scientific papers from the great British scientist Henry Cavendish, and in particular his famous work on the electric torpedo fish. He went back and took a closer look at the torpedo fish, and in particular the repeating pattern of chambers in its back. He wondered whether it was this repeating pattern that held the key to its powerful electric shock. Perhaps each chamber was like his coins and spoon, each generating a tiny amount of electricity. And perhaps the fish's powerful shock results from the pattern of chambers repeating over and over again. With growing confidence in his new ideas, Volta decided to fight back by building his own artificial version of the torpedo fish. So he copied the torpedo fish by repeating its pattern, but using metal. Here's what he did. He took a copper metal plate and then placed above it a piece of card soaked in dilute acid. Then above that, he took another metal and placed it on top. What he had here was exactly the same thing as Galvani's two wires. But now, Volta repeated the process. What he was doing here was building a pile of metal. In fact, his invention became known as the pile. But it's what it could do that was the really incredible revelation. Volta then tried his pile out on himself by getting two wires and attaching them to each end of the pile and bringing the other ends to touch his tongue. He could actually taste the electricity. This time it was more powerful than normal, and it was constant. He'd created the first battery.
The machine was no longer an electrical and mechanical machine. It was just a purely electrical machine. So he proved that a machine imitating the fish could work, that what he called the metal or contact electricity of different metals could work. And that he regarded as his final winning move in the controversy with Galvani.
What Volta's pile showed was that you could develop all the phenomena of animal electricity without any animals being present. So, from the voltaic point of view, it seemed as if Galvani was wrong. There's nothing special about the electricity in animals. It's electricity, and it can be completely mimicked by this artificial pile.
But the biggest surprise for Volta was that the electricity it generated was continuous. In fact, it poured out like water in a stream. And just as in a stream where the measure of the amount of water flowing is called a current, so the electricity flowing out of the pile became known as an electrical current. "200 years after Volta, we finally understand what electricity actually is. The atoms in metals, like all atoms, have electrically charged electrons surrounding a nucleus. But in metals, the atoms share their outer electrons with each other in a unique way, which means they can move from one atom to the next. If those electrons move in the same direction at the same time, the cumulative effect is a movement of electric charge. This flow of electrons is what we call an electric current." Within weeks of Volta publishing details of his pile, scientists were discovering something incredible about what it could do. Its effect on ordinary water was completely unexpected. The constant stream of electric charge into the water was ripping it up into its constituent parts, the gases, oxygen and hydrogen. Electricity was heralding the dawn of a new age where electricity ceased being a mere curiosity and started being genuinely useful. With constant flowing current electricity, new chemical elements could be isolated with ease, and this laid the foundations for chemistry, physics, and modern industry. Volta's pile changed everything. The pile made Volta an international celebrity, feted by the powerful and the rich. In recognition, a fundamental measure of electricity was named in his honor, the volt. But his scientific adversary didn't fare quite so well. Luigi Alizio Galvani died on the 4th of December 1798, depressed and in poverty. For me, though, it's not the invention of the battery that marks the crucial turning point in the story of electricity. It's what happened next. It took place in London's Royal Institution. It was a moment that marked the end of one era and the beginning of another. It was overseen by Humphrey Davy, the first of a new generation of electricians, young, confident, and fascinated by the possibilities of continuous electrical current. So in 1808, he built the world's largest battery. It filled an entire room underneath the Royal Institution. It had over 800 individual voltaic piles attached together. It must have hissed and breathed sulphurous fumes. In a darkened room lit by centuries-old technology, candles and oil lamps, Davy connected his battery to 2 carbon filaments and brought the tips together. The continuous flow of electricity from the battery through the filaments leapt across the gap, giving rise to a constant and blindingly bright spark. Out of the darkness came the light. Davy's arc light truly symbolises the end of one era and the beginning of our era, the era of electricity. But there's a truly grisly coda to this story. In 1803, Galvani's nephew, one Giovanni Aldini, came to London with a terrifying new experiment. A convicted murderer called George Forster had just been hanged in Newgate, and when the body was cut down from the gallows, it was brought directly to the lecture theatre where Aldini started his macabre work. Using a voltaic pile, he began to apply an electric current to the dead man's body. Then, Aldini put one electrical conductor in the dead man's anus and the other at the top of his spine. Forster's limp dead body sat bolt upright and his spine arched and twisted. For a moment, it seemed as though the dead body had been brought back to life. It appeared as though electricity might have the power of resurrection. And this made a profound impact on a young writer called Mary Shelley. Mary Shelley wrote one of the most powerful and enduring stories ever. Based partly here on Lake Como, Frankenstein tells the story of a scientist, a galvanist, probably based on Aldini, who brings a monster to life using electricity. And then, disgusted by his own arrogance, he abandons his creation. Just like Davy's arc lamp, this book symbolises changing times. The end of the era of miracles and romance, and the beginning of the era of rationality, industry and science. And it's that new age we explore in the next programme. Because at the start of the 19th century, scientists realised that electricity was intimately connected with another of nature's mysterious forces, magnetism. And that realisation would completely transform our world. To find out more about the story of electricity and to put your power knowledge to the test, try the Open University's interactive energy game. Go to bbc.co.uk/electricity and follow links to the Open University.
Coming up here on BBC HD this evening, stay with us as Mark Lawson interviews comedian and actor Rob Brydon.